Hi guys. All right, so we're just gonna start real quick. Basically, everyone's just gonna have a couple minutes to tell you what their poster's about, and then you'll have a chance to walk around. Everyone will stand by their poster so you can walk around, look at their research, ask questions. But this is really just to see kind of a general idea of what everybody's doing. So Alyssa, I will let you.
Hi everybody, I'm Alyssa and I'm going to be talking to you today about my senior thesis senior design project. Okay, so 250,000. This is the number of deaths caused by cervical cancer a year. Now cervical cancer is not difficult to treat. Cervical cancer is actually a very easily preventable disease if it is diagnosed early. Unfortunately, these locations with the highest incidence of cervical cancer, low resource settings, are also the places where diagnostics is incredibly difficult. So my senior design project set out to change that. So what are some of the problems with low resource settings? Low resource setting or cervical cancer diagnostics have problems with use of complicated machinery like thermocyclers and highly specialized training and equipment. So this is a huge barrier to use of current diagnostics of cervical cancer in low resource settings. Another huge barrier is physical. It's difficult for people to travel to clinics. It's difficult for clinicians to get results back to patients after they have learned whether or not they are positive for cervical cancer. So our lab has developed a paper-fluidic human papillomavirus test platform for low resource settings. Now, human papillomavirus causes 99% of cervical cancers and is much easier to diagnose than cervical cancer on its own. And that's why our lab decided to focus on it. So this is actually an image of our current iteration of the device with a Charlie card for scale. So how does our device specifically solve the problem of HPV diagnostics? So it's robust and easily transportable. As you saw in the previous image, it's small. The image on the far right is an expanded view of our device. It's made up of many components, but the user doesn't have to interact with anything except for the external. It's also made out of highly robust plastic, so it can be manufacturable in mass and shipped out to places where it's most needed. It's also a point-of-care device. We have solved the challenge of using complicated equipment by paring down what is needed to only a pipette and a hot plate, or potentially a hand warmer. You just need a heat source. So, and if you have more questions about about the assay that we developed, you can come and talk to me at my poster. We've also made it so that it's very easy to understand and to read. So instead of requiring specialized training to understand the results, we have something that looks very similar to a pregnancy test, where 2 lines means that you're positive for HPV and one line means that you're negative for HPV. And so we hope that this platform can actually be deployed in low resource settings and can greatly decrease the risk of cervical cancer worldwide. I'd like to thank the Clapperidge Lab and Kilachon and BU for supporting this project, and I'd like to give a special thanks to my partner, Calvin Lin, and our project advisor, Lena, who came here today, and Professor Capote, who's overseeing the project. Thank you, guys.
Hi everyone, my name is Samantha Santoro. So I've long been interested in fashion and the fashion industry, but when I tried to tie it to my academics, I was usually discouraged. So for my Keystone, I decided to finally push back against that. And I found this quote from the blog Man Repeller that says, "The conviction that an interest in fashion doesn't minimize one's intellect." So kind of armed with that idea, you may laugh, but you know, sometimes people say things. I completely designed, wrote, and edited 2 mini issues of a magazine called Style Conscious. Through it, I'm trying to kind of take a deeper dive into the fashion industry and look at clothing and its effects on different aspects of life in a deeper way. So my first issue is about the connection between fashion and personal identity. I did a scholarly research article where I researched aspects of fashion and about theories of identity. And I kind of found that, I concluded that fashion can turn the body into a communicative tool. So that these very difficult to articulate aspects of your identity can be visually represented in ways that other people can look at you and understand, even if they don't really they don't know why they understand. You can see what you can't articulate. So I think that's pretty cool. I also profiled a couple of my friends, including an article about my friend and her journey with gender fluidity. excuse me, and where clothing kind of fit in with that. My second issue is about the environmental effects of the fashion industry. Unfortunately, it's one of the world's biggest polluters and producers of waste. So I did a research article all about that, such as the disgusting amount of water it takes to create one cotton t-shirt that I'm sure half of you are wearing. And then I also did a couple articles about small changes you can make to reduce your footprint. I also ended that article, or that issue, with a photo shoot fashion spread that I completely styled, shot, and then edited myself that used only clothes from Goodwill to prove that thrifted clothing can be cute and it's a good way to reduce your fashion waste. But in the end, I just hope the Style Conscious kind of makes you think about what you're wearing, whether that's in response or connection to yourself, to the environment, and then other things. And I tried to approach fashion in a scholarly way while still respecting the aesthetic and fun outlet that it is. Thank you.
Hi everybody, I'm Hannah and this is Ryan, and we did our senior design project through the College of Engineering, and it's called Engineering a Neural Organoid Interface.
So we worked with Draper Labs in Cambridge, Mass. On this project, and to put our project into context, more than 50 million Americans are affected by some sort of neurological disorder each year. And so as you can imagine, there's a lot of research effort into this field, and these research efforts primarily rely on post-mortem tissue samples, 2D organs on a chip, and 3D organoids, which are essentially miniature brains that are grown in vitro, and that's what this project focused on. So although the biology behind organoid differentiation, so when you take stem cells and sort of allow them to grow into these organoids, the biology behind that's already widely known and studied. However, we noted that there was a fundamental lack of engineering approach when it came to the protocols themselves. And so this entire project was aimed at identifying the shortcomings of current organoid culturing methods, as well as to sort of try and identify if we could redefine the protocols themselves. So if this sounds interesting to you on how we tried to grow a brain, we'll be presenting our poster outside, and we'll also be trying to be as vague as possible so we don't violate our non-disclosure agreement. Thanks.
Hello, my name is Dylan Harina. I also did my senior design project with the College of Engineering in computer engineering. It is a solar tracking telescope mount. In computer engineering, how it works is they allow you to make a product that somebody assigns to you. So I didn't have much of a say in what I did, but I hope that I did as good of a job as they wanted me to. So we were, me and a group of 4 other computer and electrical engineers were tasked with making a telescope mount for a professor here at BU who likes to look at the sun in his spare time. He looks at sunspots and solar flares, but he has arthritis, so it's hard for him to align the telescope by himself. So we made a telescope mount that you can control from an iPhone to align with the sun automatically. It has motors and a GPS and everything. It does it all by itself. I have the telescope mount outside. You can see it at my poster. I have a video demo where you'll see it align with the sun. There is also a camera that fits into the telescope eyepiece that streams directly to the phone, so everything is controlled directly from the phone. There is no interaction that is going to hurt the professor's hands. Yeah, if you are interested in that, you can drop on by. I think it's pretty cool. That's about it.
Hi everyone, I'm Alessandra Sotaro, and I did my research project on barriers to sexual assault reporting at BU under Sophie Godley. So I started this project when I looked at BU's 2015 climate survey. According to the respondents, 18% of BU students experienced sexual violence while they were at the university, and only 6% of the survivors reported to on-campus resources. So that made me ask, why aren't survivors reporting? What happens when they do report, and how do demographics affect this? And after doing qualitative interviews, I came up with this little information cycle here. So many of the survivors I talked to had a experience reporting. So here's one survivor quote. "I didn't know who to tell because I was really new, so I told my friend. She took me to the BU police, and that was not taken seriously at all. I felt like I had no help or support." This was a recurring theme among survivors, and they went and told their stories to other students. This then became some common knowledge. For example, one of the subjects I talked to said that her first warning about, how bad the sexual assault response system was here came at freshman orientation from her orientation leader. Then the students I interviewed said that they would caution survivors who were thinking about reporting. And this then in turn negatively affects the reporting rates. One of the subjects said, "I feel like if more people had confidence that they would be treated with respect and dignity and sincerity, that they would report." So if you come by my poster, you can see some other results that I have, including the methodology and other results, as well as suggestions for change. And I also just want to take a moment to thank all the subjects and survivors who spoke to me and were brave enough to share their stories. I am so grateful that you trusted me with this, and I hope I can make a change. So, thank you.
Hello, I'm Lauren Gustanis. I'm studying speech, language, and hearing science in Sargent College, and I did an experiment in the Communication Neuroscience Research Laboratory within Sargent College. So many thanks to them, to Tyler Parashon, my advisor, and to everyone in the lab who helped out. So I studied whether talker expectations could be formed by visual cues. So one problem or big question in speech perception is, how do we recognize words? It's something that we take for granted, but if I've learned one thing in studying speech, it's that nothing is simple. So the fact that we do recognize words is actually kind of amazing, since we don't say them the same every time, and certainly I don't say words the same way that you do, even if we're saying the same word. So we looked at different things that can help you recognize words in previous experiments. So we know that hearing just one person talk rather than people alternating speaking actually helps you process words more quickly. And then we also know that hearing someone's voice before a word helps you to process that more quickly as well. So it makes us think, okay, so if you know who's talking, or if you maybe get a clue as to who's talking from their voice, then you're able to do that more quickly. And we're wondering if that's because you're hearing their voice, if you're getting some kind of auditory information from them, or if it's simply accessing a memory or something like that. So we wanted to look at if you saw a picture associated with a speaker beforehand, whether that would also help you to do that more quickly. So to find out, you'll have to come see my poster. Yeah, thank you very much.
All right, so my name is Ravi, and I'm studying human physiology in Sargent College. So my project is looking at a public health crisis that has currently been labeled a national health emergency. So currently, overdoses are the leading cause of accidental death in the United States, surpassing motor vehicle accidents. Currently, we see a 30% increase in the past year alone in overdoses on opiates, which constitutes 66% of overall deaths by overdose. So my project is looking to answer two main questions about naloxone. So naloxone is an antagonist, an opioid antagonist, and it's delivered to patients who have overdosed. And it acts by replacing opioids at opiate receptors in the body systems to replace its effects, basically saving a person's life. So my project is looking at how naloxone is delivered, as well as how can we deliver it better. So the importance of time delivery shows us that we need to know how to properly deliver naloxone in order to properly address the opioid epidemic that is currently going on. And if you have any more questions or want to learn more, you can stop by my poster.
Hi everyone, my name is Adam Dimanshteyan, and I am exploring certain elements of game theory through creating a feature film. So basically, My film explores the quintessential kind of problem in game theory, which is called the prisoner's dilemma. It's a little too extensive to explain quickly, but essentially the central finding of it is that in an interpersonal situation where people have uncertainty, people usually choose any sort of control they can over cooperation or even their own best interest, which a lot of people find puzzling and which is hard to understand. So to explain this abstract humanistic phenomenon, I basically made a film where the main character represents principles of the prisoner's dilemma, or is, so to speak, the prisoner, and explore it through his character arc. So I have a trailer here. There you go. Okay, thanks.
How have you been? Like emotionally?
It's been tough, you know? It'd be nice if I could get back on my feet before I had enough about me, you know? Hey, Randy. I was thinking about your offer.
I'm just surprised a couple months ago you didn't want a deal.
Well, a couple of months ago, I wasn't doing me.
I think there might be something going on at the school.
Daniel, can you hear me? You know everything you need to know.
I'm just making sure you're not spiraling out of control or something.
Dude, I am spiraling to stay in control.
Yeah, thank you, everyone. Anybody that would like to know more, please speak with me at my...
Hi everyone, my name is Tyrone Ho, and today I'll be talking to you about creating adaptive traffic lights using machine learning. So in recent years in the tech industry, there's been a lot of hype about this thing called a self-driving car. And so the main advantage of these things are, number one, that the human driver essentially doesn't have to drive the car. So when you're in the car, you can spend a lot of time doing things that you actually care about. So like being on your phone, on Facebook, playing mobile games, you know. And so in order to do this, you need to have an appropriate number of vehicles on the car to get these things called fleet effects. But I won't talk too much about self-driving cars because there's actually two big problems with them in the current real-world day. So the first one is that people typically tend not to trust machines driving cars over human driving cars. These cars tend to conjure up images of, the Terminator or HAL from Space Odyssey 2001, et cetera. And the second problem is that they're actually not really ready to be driven in real-world conditions. So recently, actually, Boston allowed a company called Nutonomy to test self-driving cars in the Seaport District. But about a month ago, they actually revoked they told them to essentially pause their testing. I don't exactly know the reasons, but that goes back to my first point, ties into the first point that people aren't really trusting of self-driving cars. So until the point where they're ready for real-world traffic conditions, we're still going to need things like traffic lights to deal with the terrible traffic conditions we have in places like our very own Boston. And so to that end, my project is about creating adaptive traffic lights. Because the problem with traffic lights nowadays most traffic lights, is that they are fixed time traffic controllers. And so this means that it's simply that the phase of red lights and green lights is set beforehand and then never changes. So it won't respond to changes in real-world traffic like rush hour or changes in traffic conditions throughout the day. So to that end, my project is based on creating adaptive traffic lights that take in is able to account for real-world traffic conditions using something called machine learning, which is a field that relies on probability and statistics in order to learn patterns about data. If you want to learn more about that, you can come by my poster.
Last one. Almost through here. All right. I'm just going to skip that because it basically says the same thing as the next one. Hi, everybody. I'm Matt Thacker. I'm the last person to talk to you today, so I'm going to try and keep it short and sweet. That right there, that little happy turtle guy, he's called the Southern River Terrapin, also known as Bata grubaska. Ooh, I hope it's not the northern one. I might have messed that up. But the point is, that's a turtle. It's about this big, kind of in shell shape, this deep. And it's native to Southeast Asia, including Cambodia, and it's also under a really high degree of threat. It's listed as endangered on the International Union of Conservation's red list, as well as just we've seen the population numbers drop in recent decades. So a big part of that is because Cambodia and other countries in Southeast Asia have undergone significant economic and human development, which is awesome, but that also causes a lot of land use change, a lot of forests being converted to farms or cities, and that can take away habitat, which is one of the major drivers in species extinction and biodiversity loss. So what I did is I mapped the potential available habitat for this guy, his cousin, the northern river terrapin, as well as a species of crocodile known as the Siamese crocodile, and potential threats to that habitat in Cambodia. If you want to learn more about what those maps look like or how I did it, talk to me afterwards.